Alright, 2.2 definition, distribution shapes. Alright, so I'm going to make three pictures here. The first one is called normally distributed, and it's when you have a bell-shaped curve. Now, if I was to do a couple of things on here, like mark the average, which would be right in the middle, or mark the median, which would also be right in the middle, because as a bell-shaped curve, everything is symmetric, right? Everything is balanced. For every up, there is a down. Now, I could make something which is called a right skew, and it looks like a bell curve, except it rises really quickly and then tapers off really slowly. All right, so what's going on here is I have my median, which is going to be close to the very top of the shape, and then I have my average, which has been pulled to the right, which is why we call it right skewed. Now, I could reverse this shape and do a mirror image of it and have it slowly rise up and then quickly drop off, in which case my mean, here, let me make the picture, my mean would have been pulled to the left, and I would call it a left skewed graph. And the median would be, again, closer to the center. Now, we haven't talked about median, we haven't talked about mean, we haven't talked about average, right? I just wanted to get us used to the terms right skewed and left skewed because this will come up a lot, especially in specific settings in the work world. Now, if we look in the book and we look at the actual graphs that they gave us, they gave us a couple more. Other than bell-shaped, which is balanced, they also gave us uniform, where, that's the one on the upper right here, everything is about level. There's J-shaped, which I really don't like the name J-shaped. I like to think of that as exponentially growing, where it's slow growth in the beginning and then jumps up. And reverse J-shaped is just exponential decay. Think about a half-life from biology or from geology when you're talking about radioactive material. Okay, they also have right skewed and left skewed, which is that same idea where instead of being balanced for bell-shaped, it got pulled one way or the other way to make it left or right. Now, there's also this term bimodal, meaning there's two modes, which means there's two equally as big. And see how it has two humps? That's why it's called bi for two, modal, mode being the most. There's also U-shaped, which starts off high, dips down, and then goes back up. I think about serving lunch versus dinner at a restaurant. It has this sort of shape to it. All right, now we are going to get more into these shapes later on when we look at discrete probabilities. But for now, this is just an overview of the different shapes.